So, let's call the lights. Oh, okay.
I think so, yeah.
I don't know.
So I've been using Sumatra for about the last 5 months, and originally I wanted to write my own tool for managing numerical simulations, but looking around I found that there was something already available. So that's what basically Sumatra is. I want to motivate this talk by showing a video. This is a talk by a guy called Tim Clem. He's a GitHub guy, and this was at the Scientific Python talk last year, and it's kind of pertinent to reproducible research.
ID, so
So I'll turn it up.
and a lot of these stories, I think, even in the early days, is this element of like needing to embrace failure, but learning from your mistakes. And often the traditional way of learning from your mistakes is to put a bunch of rules around things, is to basically build up a bureaucracy. Chris Wanstead, the CEO until very recently, and basically one of the first employees, founders, dropped the production database at one point in our history, and we had backups and all that kind of stuff. But it was like, it's a big mistake to make. Like that affects a lot of people, and I think in many organizations you would then build up this like checklist, before you run database code on production, you must get signed off by these 4 people. And instead, our approach has always been, people need to have the freedom to make these failures, but we need to automate away the ability to make dumb mistakes. And so that's really what we've done more than anything else. We always look for a way to basically build intelligence and automation into the system, as opposed to building physical or manual or human-based process around it.
So we don't want to write a manual for reproducible research. We want to automate it, basically. So this is what Sumatra hope to achieve with something like Sumatra. So let's take the most simple example I can think of. This is just a script which takes an argument and it waits for some amount of time. So just time.sleep for whatever the value of wait is. So this is a workflow. You run the script, you wait for 6 seconds, you then edit the script, and then you run it again. And there's no history associated with that workflow. You've done something, you haven't recorded anything about it. So one thing you can do is to invent a scheme for version control. So you can look at that and say, well, I'll keep copies of the script. Every time I edit it, I'll keep another copy in the file system. So doing that, you're basically inventing a scheme for version control at that point. And that is how I worked up until about 2006. That's how I did all my research. Copying scripts from one to the other and trying to remember what they did.
Taking directories and clever names.
Yeah. So, of course, there's a better way, and that's you can use a version control system like Git, which records every when you make a change and you decide to commit it, it records that instance of the script. So with Git, you can say git init in the directory with the script. You've created a database in that directory. Storing that script in the database is a 2-step process with Git. So you git add the script.py and you git commit the script.py. And then you hopefully give it a sensible message so that it means something later. That's basically all version control is. So then with our workflow, what are we doing? We edit the script and then we run the script again. So then I can store the new version of the script with the same process. I can add it and I commit it and give a sensible log message. So now I've developed some history of that script. I have 2 commits. I have the first and second commit, and they have labels. They have unique IDs. Those are unique IDs in the universe. So you're developing some history of what happened. You can also query the history. So you can look at the difference between those 2 commits and see what's changed. And you can imagine this can get more and more complicated. You can have branching and merging, and it's a very powerful way to remember what you've done using version control. And most of us hopefully use version control if we're doing any development at all. So version control is really good, but what it doesn't do is record the events. So when I run that script, that is a particular event. It's not being recorded by the version control. Now again, you can invent a scheme for recording that. So you might write the output to a file with a label and then commit that file to the repository, and you have some connection between the output file and the script that you used. Okay? But then you're inventing an ad hoc system. So this is analogous to version control. You're using an ad hoc system to record these events. And that's what I'm trying to move away from in my work, basically. So Sumatra is similar to Git in some ways. So you say SMT init and give the repository a name. You then configure the repository. You say, you tell it about the executable, you tell it about the script that you want to run, and then you run the simulation. Instead of saying Python script.py with some arguments, you then say SMT run with the same arguments. And then that creates a record in the Sumatra repository. So using this system, you're then recording those events. So once you've executed a simulation with Sumatra, you then can say SMT list, and then you can look at the entry for that particular record. So there's two labels there. There's a label for the particular record associated with the simulation you've just run, and there's a version. The version corresponds to the Git. The Git commit that you used, that script.py is associated with. So those two labels are the most important thing to record. Basically, you have to have. So you have two separate labels there.
So Daniel, I'm sorry, I missed something. The relationship between this and Git. Do you have to use a Git repository for the execution?
Well, you just have to have some version control. Some sort, but you can either use Subversion,
So it
Git,
just needs to know,
CVS.
and you can specify that as just another subset of commands that it knows about.
Yeah, it knows about a bunch of different version control
Okay.
systems.
It's got that part.
Yeah, so it does a checkout when you run when you SMT run. It does a Git checkout of a particular version that you run or a branch that you specify.
But you are running both a version control system when you're doing code development, and then you're doing a workflow management for your simulation runs in Sumatra.
Yeah.
You're using two separate
So
tools.
you're using, yeah. So the .smt directory sits in beside the .git directory. But that you don't commit the .smt directory to the Git repository.
You can get yourself into
Yes.
I can try to do that.
So this is this was the sort of command line interface to viewing the record, and this is the web interface. So this particular record. This is actually a live server running this right now for this particular record. So it's got the label, and you can actually edit the record from the web interface. You can add these. You can add some fields. You can delete the record. And if this was a more complicated example, it would record more. So it draws a distinction between parameters, input files, output files, and dependencies, and it records all of those, and it also records the platform information. But importantly, it's recorded the standard out and standard error for this particular simulation or event. So now I'm going to modify the code. Here I import a module, PhyPy. And this is just because PhyPy is something that I'm currently hacking, or I have the working copy in my directory, and I'm hacking it. So I want to see I want to record that particular dependency when I run Sumatra. So here is another record that I've run, and PhyPy is recorded. The fact that I imported PhyPy and the version of PhyPy is recorded. So any other packages that I'm working on are recorded. The Git version of those is also recorded. And if I hadn't committed that particular, if I hadn't made commits to that this working copy, the diff would also be shown here. So that's really powerful, being able to work on a bunch of different packages and recording all that information every time you run, you execute an event.
System architecture and stuff like that.
Oh yeah, but that's that's just it's just
I'm
running.
curious, how complete is the? Okay.
Yeah, so it's got platform. So this is the this is the web interface again. Unfortunately, it's a bit messed up because of the screen resolution. I don't know what's going on here. So these are the two records. This is the record before I edited it, and this is the record after I edited it. So you can actually compare these two. So I'm comparing the two records here. Unfortunately, this is also messed up because of the screen resolution of the projector. So, and you can also launch a simulation from the web interface. So if you click on new record, you can launch a simulation, and you can search on tags and labels and so on, and other when the job was launched, this type of thing. So this is Sumatra on Olu. Olu's just it compiles statistics about packages, so you can get a feel for, how many people are working on it, how many commits there have been. So with Sumatra, there have been 571 commits to the repository. That isn't that many. So PhyPy, for example, has over 5,000 commits. So that's not a whole lot, but it has 6 contributors, which is that's a good sign. Depends how much you want these projects to be spread about amongst quite a few people, ideally. Andrew Davison is the principal investigator. I'll talk more about him on the next slide. But the lines of code is increasing year on year, which is a good sign as well. And Conrad Hinson is someone I recognize from other projects. So that also is a good sign. And the contributors per month it's above 1 for some months, which again is good. So this is Andrew Davison. The important thing about him is that he is a scientist that runs simulations. He isn't a computer scientist that just decided to do this. He uses this every day. So I think that's really important when you're looking at this type of project, having someone that actually uses it. He's works on neural networks, and he's written a number of other packages. One of the other ones is PyNN, which is a neural network package for simulating neural networks, and that's quite widely used from what I can tell. He works in France. He's at one of the CNRS institutes in France. So why do I like Sumatra? Well, it doesn't really change the way I work very much. So instead of running that line of code there, I can run this line of code here. It's not changing my world. It's not requiring me to go into a GUI and completely change the way I work. It's really kind of a simple change to the way I work. So
you have to have at least one more step that you haven't been nice enough to show us, which is the commit of the modified code.
you don't have to commit the code. as long as it's sitting in the Git repository, it will record the diff between the last commit and the new, the working code that you're using.
Okay, sorry for that. So really, literally, once you set up the Sumatra space, you're good to go.
Yeah, but I mean, you want to obviously use the version control as much as possible.
I'm not.
Well,
I just.
Is that always changed? Because I thought earlier when we were talking about Sumatra, I thought it required.
No, not anymore. It's changed it now. Yeah. So there are a number of issues with Sumatra that I've come across. The most important of which is basically concurrency. So with the current version of Sumatra, if you launch 100 simulations at once, and they're short-lived simulations, maybe just 10 seconds, a bunch of those won't get committed to the repository because of this issue with SQLite, where it can't handle lots of queries at once. SQLite is a really lightweight database for basically testing websites. It's not heavyweight at all. So the default database for Sumatra is SQLite. And something I've been working on recently is making Sumatra work with Postgres, which is really a small change, but it has to get submitted back, patched back to the main repository.
So this would be your contribution to Sumatra?
Yeah,
Fixing Sumatra?
yeah.
Oh,
So we basically, yeah. So the other thing is live inspection. By default, Sumatra only records the simulation at the end of the simulation. You don't know you've ever run if the simulation fell over or it was suspended or something happened, you wouldn't know you ever run a simulation with the current version of Sumatra. So that has something that just needs to get fixed. It's a disaster, really, if you can't.
Don't use Sumatra.
But you can actually get around this using the Sumatra API, actually. But
So does Andrew, what's his name, not run on a cluster?
He does, but I think the neural network simulations are just not different from material science. I just think he's doing short-lived.
Yeah,
I just don't get
run
it.
things that go for very long.
And you don't run on it. You don't run a bunch of them at once on a shared file system,
Yeah.
which is the SQLite.
Yeah,
problem.
that's what's
Then
happening.
you're not going to run it. But yeah, if something's running for days, multiple weeks, or whatever, then even if it didn't fall over, you might want some record that it was running.
Right, so you just need to interrogate it.
So then the third thing really is parallel, distributed, and queuing systems. SunGrid Engine being one. It's how does it play with those? How does it play with queuing systems? How does it work with parallel jobs? Right now, of course, you can launch a job, and so you can say SMT run, MPI run. So you can launch it, MPI run. SMT knows that you've launched an MPI run job, but it doesn't know about all the nodes that the MPI run is using. So that sort of relates to inspection. So it has to know about the where the jobs are being run, and it currently doesn't know that. So this is an active research example that I'm working on. This is the web interface. It takes a long time to load because there's a lot of records in here, and it's using SQLite. This is an example where Postgres will make this much faster. So I've got a bunch of different tags for each simulation, and one thing that happens is, so I have a version of the code. This is the version of the code that I use to run the simulation, and then I can do a diff on that and see what changed. So I didn't do a commit before I run the simulation, but I can still see the changes that were made when I ran the simulation. And it's also records the data files that are produced. So if you tell it which directory you write to, it looks in there at the end of the simulation and says, okay, these files have appeared, I'll record these as output files. And it also takes the hash of the data file. So what that means is that you can then start comparing records and see that the hashes are the same. So you know that this is replication, reproducibility. And parameters are special, so you have to say, oh, these are parameters to Sumatra. So it knows about those as, I mean, everything is a sort of parameter, but you have to say, when something's a parameter, that allows you to search on that. That's really important. You don't just want to search on tags and things you have to think about beforehand. You want to search on stuff afterwards that you didn't think that this would be important simulation, and it turned out to be an important simulation for this particular parameter. You want to be able to search on that and find it, so you can do that. You can do that with the API.
How is it defined? How does it determine?
Well, you put parameters in a file, or you pass them as command line arguments, and then it knows that those are parameters. So you have to put the parameters in a file.
Okay.
Otherwise, so if the parameters are buried in the script, it won't know that those are parameters. It will just think that's source code right now.
Yeah.
So I mean that's intelligence that could be built into it, but. Okay, so this is, I wanted to show this because it just shows the way to tabulate the results. So this is the IPython notebook. I'm writing up, so the previous, what I showed you previously was a Sumatra repository, and here I'm just writing up the results from that in an IPython notebook. So here I'm I'm extracting the records based on a parameter value, and then plotting that table in an IPython notebook. So I've created this object, which is a function which creates a table in the IPython notebook. And this, so this is a movie of that particular simulation. But what's important is that I've then tagged in here. I've added the Sumatra record, so I know where that record is now of that particular movie. Now this isn't automated, obviously. I had to do that by hand. But to automate that, so here I extract a bunch of records. I then create a viewer object that displays those records, but those same records that I'm then plotting in a table here. So these images are connected to these Sumatra records. So I have a history of what's been going on. So I have the image with the record, and that's really important.
Yeah, I have to apologize. I have to go. I have a bus.
Go for it.
But I hope the rest of the group stays in as.
So why is IPython Notebook a big deal? Basically, you can embed live code with documentation on the web. Okay, that is why it's good, and it's dynamic. Okay, it's not a static blog post. This is a dynamic thing. That's why IPython is really powerful, and I think that trying to make that point is important. And so this is taking that the IPython notebook and rendering it as a blog post. So sometimes static, that's dynamic. The IPython notebook's dynamic. Sometimes you want to render that as a static document, and this is extracting that and rendering it so it's the same thing, but now this is a static document in a blog post. Okay. And that's basically, at the moment, you can do that with a few commands using something called mbconvert, and that in the next version of IPython, that will be in the IPython notebook, that you could just produce posts like this straight from an IPython notebook. Okay, and also we have an API to Sumatra. It's written in Python. You can just use the API to create records and save records, and so you create the record, you do some commands before you run the simulation, and then afterwards you'd save the record. So you don't have to use the command line, you could always use the Sumatra API. So future work on this, get this Postgres business sorted out, it's important. Live inspection, I talked about that. Improvements to the web interface, And this also has there's a lot of promise in hooking up the Sumatra repository to a Billbot, which automates testing. So then you'd be able to test different records. When something changes in your environment, you'd launch a whole bunch of special simulations that you've tagged, and then you'd be able to check that the hash hasn't changed for the data file. And the other thing is distributed. Is at the moment Sumatra sits in one particular directory. How do you share that with? So you run simulations on different machines and so on that aren't connected. How does it work with? How do you get a distributed Sumatra?